For this video on a super fun Saturday before spring break, on a nice rainy day, I think it's time to do some Hess's Law practice. So, Hess's Law is from Chapter 5 for Gen Chem 1 students, but also a lot of other people are tortured with it, which, no, I'm just kidding. I actually really enjoy this Hess's Law. What's nice about it is when you're right and you're correct, there's no doubt in your mind. So, what'll happen is you'll get a problem and it'll say calculate the enthalpy of this reaction, so it'll give you a reaction using information from the first two reactions or sometimes three reactions. So it'll give you a reaction with a known enthalpy, reaction with a known enthalpy, and then it'll give you a third reaction or fourth reaction. It'll say what's the enthalpy here, right? So that's the question. What is the enthalpy of this reaction? That's essentially what we're going to be trying to find. That's the end game. So I have my own little verbiage here and I have my own little habits. One thing that I like to do is I like to keep my arrows aligned because it makes it easy to determine which side's the left side and which side's the right side. So I like to keep my arrows aligned up above each other. And when I know for sure, so we'll talk about this. So one thing I ask my students is I say, can you identify something that shows up in my final reaction that only exists once in these previous reactions? So an answer would be P4O10, solid, right? Do you see, I see P4O10 solid only in one place right here, and I only see it once right here. So, what do I know for sure? I know for sure that P4O10 has to be on the right-hand side, and there can only be one of him. How does he look up here? He's on the right-hand side, and there's only one of him. So, can you imagine a scenario where I flip this equation or multiply this by 2 where it totals out to this? Absolutely not. So, I call this, you can't touch this one. This equation has to stay as is, right? Because I call this an anchor. That's my verbiage, that's me. So I call this an anchor because he makes sure that this has to stay on this side and there has to only be one of him. All right. How about anything else that exists only once down here? That would be P4O6. So he needs to be on the left-hand side, and there needs to only be one of him. How does he look up here? He's on the right-hand side, but there's only one of him. So what do I have to do to this? What do I have to do to this equation? I need to switch it. Do I need to multiply it by anything? No. I just need to switch it. This is, again, another thing that I would call an anchor, my P4O6. So let's rewrite it switched. So that would mean that my P4O6 is on this side now. And my P4 solid and my 3O2 would now be on this side. Right? What happens to my delta H now? Well, if you flip the reaction, the sign on delta H flips, right? So since it was a negative 1640, it's now going to become a positive 1640.1 kilojoules, right? Now, what do I do with this reaction? I am now done with it. I draw a line through it so I don't get confused anymore. We have another thing that I call another anchor, right? P4O6 has to be on this side and there has to be only one of him. So I can't move him, can I? So hypothetically, everything else should fall into place, right? So let's check and see if it actually does. what else is left over? Because we verified that he looks good, right? Because he's here, and he's here. All right. What else is left over? Well, it looks like we have a P4 on the left and a P4 on the right. What would happen to those? They would cancel out, right? Because it's used up and it's formed. All right, so they would cancel out. Now, how about the 502 and the 302? These 302 would be used up and we'd be left with 2 on this side, right? So that's exactly what it looks like. We have 2 O2s combined with my P406 and my P410, and these 2 are canceled out, right? So, since I verified that these 2 combining is this, what do I do now? I combine these 2 and it will be that. Yes. If you combine the enthalpies. So once you know that you can combine the equations and they equal your desired final equations, you can combine the enthalpies and it will be your final desired enthalpy. Don't worry, I have another example after this. But let's go ahead and write that out. So it's going to be, my delta H is going to equal whatever negative 2940.1 kilojoule plus 1640.1 kilojoule. So what is that? I get negative 1300 kilojoule. That is the answer. So let's do another one. I believe this one we involve some multiplication, so let's buckle up. So unlike my previous one, what I like to do is, again, I like to line up my arrows, and I actually like to leave a line in between, because if I have to rearrange this, I write it right here, and then I cross that one out. If I have to rewrite this one, I write it right here, and then I cross that one out. So that's usually what I do, but I don't know why I didn't anticipate that. So it looks like I need to calculate the enthalpy for the following reaction given these 2. So let's find something that appears down here only once up here. So how about SO2? All right. So it looks like SO2, I need it to be on the left-hand side, and there has to be 2 of them. What's going on with my SO2 up here? It's on the right-hand side, so it's on the wrong side, and there's only 1 of him. So what do I have to do to that equation? I need to flip and multiply by 2. I need to do both of these things. I need to flip it and multiply it by 2. So let's go ahead and write that out. If I were to flip it, I would end up with 2 SO2 on that side, and I would end up with 2 sulfur solids and 2 oxygen gases, right? So I flipped it, and I multiplied everything by 2. Now, if I did that to this, what would happen? So the sign would flip, but what else would I do to it? I would multiply it by 2. So it would become 290, what is 297 times 2? It would become a positive 594 kilojoule, right? So now, what do I do with this equation? I'm done with him. I've used him up. And I can rest my head, I can rest easy knowing that this is my anchor. Having 2 SO2s on the left, that's non-negotiable, right? All right, let's keep going. O2 appears in a couple places, so I'm not going to mess with him. But how about SO3? No SO3s. I have an SO3. Okay, so I need SO3 to be on the right-hand side, and I need there to be 2 of them. Well, it just so happens that he is on the right-hand side, and there is 2 of him. So I cannot, this is again non-negotiable. This is my anchor. He has to be on the right-hand side, and there has to be 2 of them. It just so happens that he is on the right-hand side, and there are 2 of them. So can I touch this equation? Can I multiply it? Can I flip it? No. You must leave this equation as is. So my 2 equations that I'm going to total up are this one and this one. So let's go ahead and do that. So let's check everything and make sure everything totals up. So what happens to my... Oh, I do believe that I copied the equation down wrong. This should be a 2 up here. My bad. That's a 2. Because that wouldn't balance any otherwise, right? So this is so what would happen to the rest of the gang here? So I know that this is here, okay? How about this? This. Perfect. Now, things that are left over. 2 sulfurs on the left and 2 sulfurs on the right. What's going to happen? They're going to cancel out. Right? And then what do I have left? I have 2 oxygens on the right, and I have 3 oxygens on the left. What's going to happen? 2 of these are going to cancel out, and it's going to change this to just 1. Right? 1 oxygen. So I have that right there. So my 2 reactions do in fact total up to this 3rd reaction. So what's my final step? Total up the enthalpies. So it's going to be negative, or delta H is going to equal negative 790 kilojoule plus a positive 594 kilojoule. So what is that? Negative 790 plus 594, that's negative 196. Kilojoule. So you could even put it right here. So not so shabby, not so bad. I told you these are not so bad. Once you identify I call them my anchors, the things that I know for a fact have to be on a certain side and they have to have a certain coefficient. Once you identify those, everything else should cancel out and look good. So that's how you do these guys. Alright, well everybody, good luck with that. Have fun.